Another scientist investigated an enzyme that catalyzes the following reaction: ATP converted to ADP plus PI. The scientist set up two experiments, C and L. C used the enzyme and different concentrations of ATP. L used the enzyme, different concentrations of ATP, and a sugar called lysose. The scientist measured the rate of reaction in each experiment, and the results are shown in this graph. So we can see that L, the rate of reaction is much higher than C. So our question, 5.3, tells us that lysose binds to the enzyme, suggest a reason for the difference in results shown in figure 5 with and without the lysose. So we can see that with the lysose we have the line L, and that causes an increase in the rate of reaction. C does not have that, and although there is an increase in the rate of reaction, it does not get as high as if the lysose was present. Therefore, we can conclude that with this lysose there is an increased rate of reaction, so there must be an increased number of enzyme substrate complexes forming. So if there's an increased number of these enzyme substrate complexes, this is probably due to the fact that once this lysose binds to the enzyme, it will alter the tertiary structure of the enzyme, and it will then change the shape of the active site, which will now mean that more enzyme substrate complexes can form, they can form more quickly, or it will lower the activation energy. So presence of this lysose allows more enzyme substrate complexes to form because it will alter the shape of the tertiary structure. So now it has changed the active site shape. So now it's more complementary, so more enzyme substrate complexes will form.